The fast takeoff of artificial intelligence is a lot closer than you might think. Now, if you look around, you might think, okay, well, we're making some progress, but I mean, maybe linear at best. We're augmenting human capabilities. Who cares? It's just not going that fast. But what we don't realize is that we're not even using AI yet for the way that will ultimately contribute to the exponential snowball that is the fast takeoff. And what I have in mind is this: the barrier, the principal barrier to being able to accomplish this fast takeoff is not something that I've heard anyone mention yet. It's not something that people are really talking about, and it's a very practical matter that is going to happen soon, and it's something that people are highly motivated to do. And here it is. It is simply AI being able to reliably do computer code and reliably get to a solution without getting into these dead-end loops where it can't figure out the solution. As soon as that's able to happen, even 1 out of every 10,000 times that it tries, that's going to be good enough. So we're talking about what is this? 0.01% success rate in terms of being able to reliably find an answer for a particular programming problem. 1 out of 10,000 times is terrible, right? Most people who are thinking about computer code, they're like, oh, I want it to be, 95% effective or 99% effective. I want to be able to trust its answer. But as it turns out, that really doesn't matter. And the reason that that doesn't matter is because 0.01% of the time, if it takes 10,000 tries to get something right, but it reliably will be able to get something right, well, then I don't have to be involved at all. You don't need a human programmer in that case. You just need somebody who can do the prompt. And so as soon as that's possible, then we can talk about a situation where AIs are autonomously coding throughout the day, throughout the night, all the time. And so for a human coder to say, okay, here's the prompt, give me the thing, it takes a few seconds. But if that few seconds didn't have to have the human in the loop, well, think about it, 86,000 seconds in a day, a few seconds, even generously if it was 8, 10,000 times a day, that may be about what it takes for a human programmer to solve a particular, let's say it's a piece of a, agile programming puzzle or whatever it might happen to be, a single task given to you by your manager, right? And if that's the case, then AI will already be at the pace of humanity. And that's not even necessary. It could be much slower than humanity if it was able to reliably do it on its own, sort of fire and forget sort of thing. We don't have to worry about it, give that task to the AI, and then just come back a week later and it'll be done. The reason that this is so important for the takeoff is because you use that one thing, and if I'm coding a website or a game or something of the kind, it may be slower than a human and we may not want to go there yet. That's fine. That's not what's going to cause the exponential snowball. What's going to cause the exponential snowball is having AI to improve its own code, to improve its own methods. And so if that works reliably, 1 out of every 10,000 times, that's good enough. Because even working that infrequently, if it can work autonomously, and then I can have many of these things working autonomously in parallel to improve different parts of the code, then the whole thing slowly gets raised up, and it's an exponential in terms of it improving. Because when one improvement is affected, it affects all other things. And so it just raises everything up right away. It's the same kind of thing that happened with the recent improvement for matrix multiplication. So AI was able to improve upon matrix multiplication for computers. It turns out that's really, really important. It's central to almost everything on the internet. Just being able to get rid of one assembler instruction resulted in a palpable speed up that, kind of speeds up the entire internet, so to speak. So it's that kind of phenomenon that I think we're up against. And so that's ultimately what's going to cause the exponential snowball, is having this, extremely unreliable but nevertheless consistent beginning to the takeoff, where, okay, now it can finally code on its own. As soon as it can do even somewhat mediocre code on its own, then we're going to be off to the races. And oh, by the way, people are really, really interested in doing this because the economic impact of being able to do so well is huge, which is one of the reasons that Microsoft has been so invested in doing this kind of thing, and everybody else is interested in it. So it's only a matter of time, and the gatekeeper for actually beginning this exponential snowball is not something that you hear people talk about very much.